So Exploratory version 5.3. There's a bunch of new features, but especially around this area, data wrangling, visualization, analytics. Data access, actually, there's not much in this release other than some of the enhancements around the BigQuery and the SQL editor and stuff. Okay, so let's start with analytics. Sorry. So these are the new features or enhancements. Let's go one by one. And the first one is the test mode support for statistical machine learning models. So we always supported this even before we had this support, but if you want to do like kind of evaluating your machine learning models or statistical model, typically like you want to split the data into training and testing data. And then to do, like you have to do from the command line or like data wrangling as a data wrangling step. Yeah, typically you see at the right-hand side. But when it comes to like analytics view, which is to give you the very like interactive, quick experience to interact by use analytics algorithm and stuff. That testing data, training data thing was not supported. So from this release 5.3, now like you can click on the property dialog, property menu, and then scroll down in the property, and then find the evaluation section, and then set the test mode to true. And then like, you can set like what's the percentage of the data to be reserved for the testing data. And then like you can just run it, and then this will produce basically. This will build a model based on the training data and then evaluate the model against the test data. So and then like, it depends on the what type of the model you're building. So like for example, regression model, like a classification model, and then you get the different views. But let's say like if you're building a regression model, then like when you go to the prediction tab and you see like how it's performing the training data and the testing data, between predicted values and actual values and so on. This is a residual. Like you can also see like how that residuals are between the training and then testing data. Okay, so it's pretty basic. If you're familiar with this type of the model, basically this is nothing new about this. We just provided something that you would expect. So next one is a cut point for binary classification. Binary classification is about predicting whether that is true or false. And then in that case, the important thing is like, hey, where the cutting point? Typically, let's say like 0.5. That means probability of greater than 50% becomes true, and then less than 50% becomes false, and so on. So used to be, this is a default setting, was 50%. You couldn't change it, but from 5.3, you can change it. By the way, this is again is the analytics view. Now you can change it from the command line or like the data wrangling step. Then you could do it even before. And in that case, like you have even have like optimization point mode. That means like you don't have to set manually. Like you can actually let's basically to increase the AUC or F score, and then like you can ask the system to figure out like what is the optimal cut point. In analytics view, right now we support only the manual mode. So like you want to set like let's say like 60% or 80% or something like that. Hopefully, like in the next release, we're gonna start supporting more like optimization, automatic stuff as well. So by setting the cut point, let's say like you have like you set like 50%, 0.5 is 50%. Then you get like F score and precision recall and so on. And then like when you go to the prediction metrics, you get this result. Let's say like, like I want to actually increase cut point to the 80% because you don't want to make type 2 error. You'd rather say like you don't want to make a type 1 error. You rather say like true. So no, you want to make sure the chance that like you say true is really true. So then like you can actually change that to, the 0.8 or 80%. And then like obviously like you tend to predict false more than like true. So therefore like a recall goes down and then precision goes up. If you want to go the other way, then you can decrease the cut point to 0.3 or 30%, and then your model start predicting more for true. But then this causes precision down and then recall up and so on. So there's always a trade-off. So like now, it depends on your use case. To be honest, like when you're just analyzing the data interactively, then probably this might not that matter. Like if your focus is purely like trying to figure out like what's the relationship between the variables, but if your focus is like building a better prediction model, then I think this is where like one of the things you can tune. Okay, so the next is, this is not really a new features, but we basically changed the default setting for random forest and linear regression, logistic regression. So what that means, so random forest, we had the Boruta setting. The Boruta is about when you get like a variable importance for random forest, then you get kind of confused because there's two problems with the variable importance. One is because the random forest is randomly sampling the data before ingesting that into the algorithm. So the variable importance result tend to change, and the ranking tend to change. The second problem is like when you have like, let's say like a bunch of variables, even though like the ranking, but you don't know like what are the variables that are something that like you should really take it seriously. Which variables are useful, which variables are actually not useful at all. So the Boruta actually does two things. One is run the random forest 20 times or 40 times, whatever the times you want. And then therefore, like you get the slightly or different results of the variable importance. Then like you can visualize with a box plot showing the sort of like distribution of the rankings. So then like you can compare not by just one single value of variable importance. Instead, like you can compare by the ranges of each variable. Second is because it does the binomial test behind the statistical test behind the scene for based on the 20 tests. Therefore, you can kind of see like what are the variables that are consistently good or consistently not useful. And then, so in this case, for example, the green colored one are the ones that the system thinks those are all really or always useful, and the yellow ones are not sure because maybe 20 times or like whatever the test is not enough. So like you can't say it's good or bad. So and then the gray color is always bad compared to actually I forgot to tell you is the Boruta is creating a shadow, kind of like randomly created variables. So these gray ones are not even better, even worse than those randomly created ones. So therefore, like you can kind of forget about those things. So anyway, so Boruta is really useful, especially like you're trying to use random forest for the variable importance. So this used to be like you have to go to the property and set true to enable Boruta, but because many of the users loved it, so we made this default. So drawback of making this default is that like because it run random forest 20 times at least behind the scene, so the performance gets slower, obviously, but you can turn it off if you don't like it. But we think the performance is not as bad, and then but the value of having this Boruta view is so great, so we made this the default. And another thing is a linear regression. The variable importance by basically this view also used to be like off by default because it adds a kind of a little bit of performance because behind the scene it ran to calculate R² for each variables. And there are a couple options. The simple one is just by setting each predictor variable, and then calculate the R square and just simply comparing those among the variables. Complicated one, it has a different variation to get the R square. Like a first comes or like last comes, or combination of kind of like every single combinations of the predictor variables. So once you start getting to more complicated option, like obviously the performance gets much slower. But the simple one is not as much. So we made this variable importance with the very simple one, just simply like calculating the R square for each variable. So, and then this again, the value come out from this importance, variable importance is just so great. So like we made this as a default. You can turn it off if you like. And then the logistic regression, we made this average marginal effect as a default metric under the coefficient view. So the logistic regression is a kind of a tricky one. I think we're gonna do another online session focusing on the logistic regression, but in order to interpret the result of the what you get from the logistic regression is always tricky, because the coefficient is kind of like you have to figure out, take in account that like a model is doing like a log scale transformation. Logic transformation. So it's not straightforward what the coefficient really mean. And then there's an odds ratio typically people use, but then odds ratio itself is like kind of like between what is the odds, and then the odds ratio is kind of like increase or decrease of the odds. So it's not really intuitive. So, but on the other hand, average marginal effect, which is actually used a lot in economics and in political science field, and it's much more intuitive to understand. So for example, like when you get average marginal effect of 0.2, that means 20%. So like X, let's say in this case, if most left-hand side, like I think over time, yes. So the over time, yes, the 1 point increase, this is categorical. So for example, from no to yes, over time. So when you over time, that's the over time, then 20% chance, more chance to leave the company or something. So in this case, the target value is attrition. So the chance of attrition increased 20% average. But this way of interpreting or understanding is much more intuitive. So this is a default now. You can change it between odds ratio and coefficient. And when you turn on, when you go with this average marginal effect, we don't show the confidence interval by default. You can turn it on. The reason we turn it off is because the performance gets slower. So if you don't mind, then like you can actually turn it on to show confidence interval. I mean, like it's always, we recommend to have the confidence interval always, but sometimes you just want to interact, and then by switching, predictor variables and stuff, and then performance is more important, then without confidence intervals might be a better option. Okay. And then the next one is a profit. We enhance some of the capability around profit. Profit is a time series forecasting algorithm. So such as extra regressor, daily seasonality, and so on. So let's go one by one. So daily seasonality. So look, we had yearly seasonality, weekly seasonality. Yearly seasonality is about like for example, if you're focusing on sales, and the sales might increase in December, but decrease in July or something like that. So you want to see that kind of seasonality, right, that you expect in every year. And weekly is like weekly, right? So like, for example, like sales goes up on Saturday, Sunday, but it goes down Monday, Tuesday. So that you can expect that kind of seasonality every week. And the same thing, the daily is during the day. So like sometimes like maybe around lunchtime, the sales always goes up and then comes down like around evening time or something like that. Then you can expect that kind of seasonality every day. So now, like if you have the scale of that date time column is hour or less than hour, then like you get this daily tab, and under that, like you can see like a daily seasonality. And the change point. So there are many, our users using this time series forecasting with Prophet, and then we get a lot of requests around this area, around the change point. Then there are many things you can do, and one of the things is a change point period. So default was, I think, 0.8 or something like that. I forgot the default value. I can check that later. But sometimes like you don't have enough data, then like you'd rather allow the entire period to have this like as a change point period. Therefore, like if you any like a trend change in the trend, like it be happen, let's say like last 2 weeks, it can be captured. So in that case, you want to increase the change point period to be like closer to 1. Or like you want to make sure like, hey, you know what, like last few weeks or last 6 months, you don't want to count any trend change, then you can actually reduce that to 0.5 or 0.3 or whatever the period. So just to visualize, so this is like when you set a change point 0.8, so that means like 80% from the beginning of the period to whatever, like 80% point of the time can be the change point period. That means any trend change happen in that can be detected in that period being considered as a change point. Therefore, the orange line is a trend, and then that trend count the curve, not the curve is because this one in particular is supposed to be straight line, but anyway, so the slope of the trend can be changed by the change point, which is visualized as the green line, green vertical line. And then if you set to 0.5, that means you the model thinks only the 50%, first 50% of the data can be used for detecting a change point. Therefore, in this case, the green bars kind of reduce down to the left side, and then the trend line only accommodate that. So anything like after that, like a trend line, is basically stay the same slope. And also we added the additive and the multiplicative mode for seasonality. And this is actually very important. Depends on your data. Let's say like your data tend to be more like kind of exponential growth type of the data. Then you want to change this to multiplicative. So often, like typically happen in the sales data. The sales usually increase like kind of a percentage. It's not like linearly. It's rather it's more like in 10% or 20% or whatever the percentage every single year. Then multiplicative will produce better results. So this is like if I applied additive on the sales data to forecast for like next 12 months or something like that. As you see that the time goes, then blue line is actual values, the orange line is the forecasted values. The difference between the blue and the orange start kind of like a wider. When I apply multiplicative, that it doesn't keep wider. Instead, like throughout the like I said, like old years, like I said, like 4 or 5 years, always the difference is kind of like a balance in among those years. So this basically produce, let's say, like a different like RMC or something other metrics. So this case, like if I again like use additive seasonality mode, then as I said, like as the time goes, then the difference between the actual and then the predicted values getting wider. So like RMC in this case is 61,000. And then on the other hand, if I apply the multiplicative, and then the difference that doesn't keep getting wider. So therefore, in this case, RMC is 45. RMC is a metric. Think of it as like a kind of like an average difference between the actual and the predicted values. So this is, you can say, for example, like it's average when you get the prediction, then typically between the range of like 45,000 up or down, something like that. Okay, so that's the profit. And then, oh yeah, then there's another one. It's called extra regressor. I didn't have that slides for that, but extra regressor is like you can basically building a time series model, forecasting model is try to detect the patterns and seasonality in the data, and then build a model, and the model produce a predicted result. But by using this thing called extra regressor, like you can actually bring in another variable. Let's say like you're focusing the sales. You can bring, let's say, the profit. You can bring in the number of the customers. You can bring in maybe like weather temperature as a predictor variable. Then you can influence the model, the predicted result by using the trend. Not the trend. It's almost like a kind of the variables, patterns, and the correlation happening between your target, in this case, for example, sales, and number of the customers or something. Okay, so I'm going to show you the demo quickly after this, so then we can take a look at it. And another thing is the power analysis. Power analysis is when you do, let's say, the t-test or chi-square test and that type of like a statistical test. Very important thing is not, of course, like you want to report a p-value, like this, and based on the p-value, you can say this difference you're seeing is statistically significant or not. But when you make that call, you want to make sure to report effect size and also the power, like how much is the power this test has. And then without those, then you can hack the p-value to your advantage or the way like you like. So there are a lot of p-hacking happening in the industry. So we started like, reporting this effect size and the power as well. And then that means also like from the property, you can do, sometimes what happen is like, hey, I see the difference, but the p-value is, let's say, like 20% or 30% or something like that. That doesn't mean the test is saying there is no difference. It's just saying that we can't say there is a difference, right? So, but that means there might be difference between a group A and a group B, or control group and treatment group. And then, typically, like we don't have enough amount of data. So then the question is how much data we need. And that's where like you can actually open the property, and then you go down to power analysis. And then like you type like a probability of type 2 error, then this will produce a required sample size. So the thing I'm talking about right now requires some of the knowledge, a little bit of knowledge in the statistical test, which is one of the sessions I'm planning to do. So if you're interested in, statistical tests or, like how you evaluate the A/B test result kind of stuff, stay tuned for that. Okay. And we added other non-parametric tests under the statistical tests, such as with Coxon and Kruskal-Wallis test. And also we added negative binomial distribution support for GLM. So, so these are the analytics update. Okay. And then the chart is, I think this chart, and then another one is the data wrangling. But these two areas, like I'm personally super excited about, especially the first two. So let's go one by one. Categorization with the numeric values, which is in the expert world, we call it like binning, but it's really when you have the numerical values, let's say sales or age or whatever, and you want to categorize, creating like 3 or 5, 10 different classes. So that's called binning. But that you can do, you don't have to use the data wrangling to do it. Now, like you can do that within the chart. So, and that turned out it's very, very useful. So let's say like you have a scatter chart, and typically like when you want to compare or understand the relationship between the two numerical variables, typically like you go to scatter chart, right? But then scatter chart is kind of sometimes helps you, sometimes not really, because when your data never be that so clean to linearly correlated. So that's when, let's say, like you can actually change, let's say, like in this case, x-axis values is working years in this organization, and the y-axis is monthly income, right? And then like you can convert that working years to categories, just like, maybe like equal with or equal frequent, whatever that could be. And then see the range for each y-axis value, in this case monthly income, by using a box plot. Then you can better, almost like to yourself too, but more importantly, like explain to others the relationship between these two numerical variables. You can change how many classes or categories you want to create, or how many times you want to cut the numbers into n categories. You can change such things as well. And then not only the box plot, you can use that for bar chart, and like basically most of the charts support this. So even the bar chart, like you can assign the numerical variables, and then you categorize them, and then like you can show, let's say, like an average. And this might be even easier for others when you present this type of relationship between the numerical variables. And then you can we support this binning or categorization of numbers with color as well. And this color is also cool. Like by using the color, like you can detect, like, let's say in this case, like I'm using monthly income in the color, and then dividing into 5 different classes based on the values. So you can see, like, the high income people, like where those people are in terms of the job role. And it turned out like a manager and a research director, because I can see the darker color here or something like that. So by using this, it's very, your exploratory data analysis can be more productive. And then, so this is where I assign age. And then, in this case, I'm basically binning or categorizing numerical values for the x-axis. So the age now is presented by, for example, like 18 to 26 years old, 26 to 34 years old, and so on. And also, like I'm using the binning at the color. So like where the high income people, what age, and that kind of stuff. And then, sometimes, especially for like, let's say like age, like I don't want the system to give me the kind of cut point. Like I want to set the cut point, like let's say like 30 years old, 40 years old, 50 years old. You can set that as well. And then you can even give it a label name if you like. Oops. Here. And then other thing is the chart limit values. And this is another convenient features. Sometimes happen is when you access, let's say like visualize with your data with a bar chart, assign something like a country to x-axis. Let's say like your country, like 160 countries, or maybe like 100 countries. Then you basically end up seeing like 100 bars or 160 bars, so on. And that is too much. And you can always zoom in inside the chart, but it's not really great when you want to display in the dashboard or note or present to other folks. So you can click on the property of the x-axis and then select the limit axis values. Then you can show, for example, top 30, top 10 countries, or bottom 10 or top 30, whatever the country is. You can use top bottom option. And also, you can use the column that is not used inside the chart. Let's say like you're showing the sales, some of the sales or something, but like you want to use different variables. Let's say like sales compensations or number of rows, and the top, like that number of the customers or something, and then you can show that result in the chart. So this is very powerful. And then not only top and bottom, like you can use a condition. So let's say, hey, I want to show like in the sales by the country, but also make sure like the countries that have greater than, let's say, like 100 orders or 100 customers, you can create such condition as well. typically becomes very convenient. Like when you have some, let's say like in this case, I'm using a map and then assigning the logical column to color by, then changing the function to percent of true. So this way, like I can show each country's return rate. And then it turned out this country, Slovenia, is return rate 100%. But actually, I know that like this country has only like 3 or 4 orders. So therefore, if you order 3 times and then like it happen to be all returned, then becomes 100%. On the other hand, let's say like France or Spain might have like 100,000 of the, maybe 100, 1,000, 10,000 orders. So it's not really good practice to bring in just on with the countries with 3 orders, for example. Then I can use that same thing, the condition and the limit values. So in this case, I said like, hey, number of rows, in this case, orders are greater than 50. Then like only the countries that matches that condition get display. Now Slovenia in this case is gone. And then the scale is now like 0 to 11% of the return rate. So this is much better view in terms of like trying to compare among the countries in terms of the return rate. So you can use this limit value setting in the different charts as well. And then we added an extra functions such as log, absolute, and also the weekend. When you assign date column, then like you can show by the month or the week or floor today, and there's a bunch of options. We added weekend there. So therefore now you can show the weekday and weekend, different color or different bars and so on. And then you can show, you can select the log function from function drop-down list. So this is actually pretty cool because sometimes, like many times, like especially like when you start using like statistical model or test or something like that, some of the models assume the distribution to be like normal distribution. And then, or not only that, like you want to see like kind of a nature of the data. So in this case, like a sales, and it's very typical. It's very skewed to the left and then kind of a long tail. But you can quickly change that to log. And then like you see, okay, so this becomes a normal distribution. So that gives you the sign indication of this data is more like kind of a multiplicative type of data and so on. So anyway, so you can use this function to quickly interact with the data. And data wrangling. So that's about a chart. And then here's the data wrangling side of things. The main thing is that this new UI for summarize, pivot, rename, and then other enhancements as well. But I think these, makes your data wrangling experience much easier than before. So here is a summarize UI. So before you had to do the group by the data frame, you have to use a group by to group the data frame or partition the data frame. Then you create a summarize, and then like you have to do one column at a time. Now all things get together in one single dialog. So you don't have to do the group by as a separate step, and you can just start with a summarize and then set the group by column. You can set multiple group by columns as well by clicking on the green plus button. And then you add the value and then set like and how you want to calculate and so on. And then we support the custom function. So not only like sum of sales, but if let's say like like some other function, you can let's say a quantile or something like you can create that expression, or you can actually do calculation of like one aggregated values and another aggregated values, dividing or so on, and it's very very powerful actually. And then pivot dialog. Pivot is like basically it's very same thing. Like you go to the chart view and then you use a pivot table. Sometimes you want to actually do that as a step. Then like you can feed that data into the machine learning model, or you can do some extra data wrangling on top of that data. And then you can create such by using this pivot dialog. we had this dialogue, but before it was kind of like a not great UI experience, so we redesigned it. So this time, I hope this is much more useful than before. And then rename, this is my personal favorite. When you import the data, typically, or like when you do some kind of data wrangling tasks, and then your column names are not great or not readable, and then so it used to be like you have to change, you could rename, but you got to do like one by one column at a time. But now like just one single dialog, and then using a tab key, and then start changing the column name. This is very much faster than you could have done before. And then this margin data frames. Margin data frames is like, let's say like you have the August data, you have the September, you have the October, all the data frames. You have the different multiple data frames, but each data frame has the exact same sort of a set of columns. And then like when you want to merge them together by rows, so like you have like September rows and October rows and so on. And then when you do, there are couple problems. Number one is you want to keep, you get kind of like a lost information of what are these rows, where these rows are coming from. So like, what are the original data frame name? Is this like a September rows or October rows and so on? So now by checking, I think it's a default, but when you merge the data, and then like you get the ID column, which stores the original data frame names. So like you always know like which rows are coming from which data frame. Another thing is like when you try to bind multiple data frames, those data frames used to have to have not only the same column names, but also the same data types. And what happens when you import, like sometimes some column becomes the date or project city, sometimes the numeric, or sometimes integer. You get like different data type accidentally most of the time. So we have this option called force data type to match. That means if the data frame have the different data type columns, the data type columns didn't match, then behind the scene, it change all the data type to the character, and then merge them together. Then run one step to automatically like detect the appropriate data type on top of this like a combined data, then return it. So looks like it's sort of like you get what you have expected basically. So that's something that some of the enhancements happen in this bind rows. Okay, so you get like ID column, and then like in the table view, you see like ID column. That's where like you see like which rows are coming from which data frame. Okay, so that's about it. And then there are other two, but I want to actually quickly show a few example as a demo here. So let's see. Number one, couple of things. Let's see here. So let's start with the data wrangling, the new UI. So for example, let's go to the table view. And then I want to show like a summarized view, summarized dialog, and also rename. And then like once I get that data transform in an aggregated format, I want to go to the chart view and show you some of the new features in the chart. And if time arose, then like I want to go to the analytics view and show like those test mode and so on. Okay, so let's say like this is like a sales data, like sales history data. And then like I want to do like RFM analysis, which is like calculating the recency and frequency and monetary. And then that's typical thing that you do to score each customer, and then like see like what type of customers you got in your hand, and then like you can provide information to the marketing or sales folks and so on. So let's do that. So here I want to basically start with summarizing like how many orders we had by counting the order date. So like I go to summarize from table header menu, summarize, then the count, a unique count. I'm going to select this. And then notice that like I haven't done like any like a group by for this data frame. And I'm going to just call unique count. And then I get these values, but this value is just one single value because I haven't done any group by. But here there's a grouping by section. I can select, like, let's say a customer ID or something. And then now, like, I get this like a count of unique number of order date for each customer ID. And then, like, I can start adding other calculation. Let's say, like, I want to calculate the sales. I want to calculate, let's say, like, calculate number of rows for each customer. I want to see like order date, but instead, like, the first order date for each customer. I want to see like the last order date for each customer, and so on. And then, so these much of the calculation have been done like in this instantly. And then click run button, and then I get this kind of result. But here is now, like, for example, like, I want to change this like name to be more readable. So let's say, like, I want to see the customer ID to be just a customer. So now here is like I can just change these column names once. So like, let's say customer, and this is the order date. So this is like basically count of the order. And then this is just the sales. And then this is number of rows. Actually, I don't really need a number of rows. So like, I'm going to just keep that as is. And then this is like, let's say like a first order. And this is last order date, maybe. Oops. And then click the hit the enter key, and then I get like a cleaner menu here. So now, like, let's say I'm gonna just do filter out like only the customers that ordered more than once. And then, like, what I'm gonna do is I'm doing an RFM analysis here. So like, I want to calculate from like last day minus first day or something. So last day minus first day. Then this is like a order period. And then, like, what I want to do is I want to calculate recency. So I want to do, let's say, YMD minus. YMD is the calculation to convert whatever the character data to date. So let's say, like, I have 2016 December 31st as the last day of this data, right? Then, like, I want to actually calculate that. So this is recency. And then I noticed that these two are diff time. Like, I want to convert these to numeric data time. So like, I'm going to select both of them and change data type and convert numeric days. I click run button, and both of them becomes numeric. And then, like, I want to actually do divide by these guys, count, divide by period, and then this is basically the frequency. Oops, I misspelled frequency. Good. Then, like, I want to divide this one by period, and this is a monetary. There we go. So now, like, I have calculated recency, frequency, monetary, RFM for each customer. So now, like, I want to go to the chart, and then I want to visualize it, right? So how am I going to visualize it? Well, let's use a heat map, and then see if I use a scatter plot here, let's say, and this is kind of a typical one thing you might be able to, you might want to do is, let's say, like, compare the recency and monetary. Recency about like how long, like since customer ordered, already days passed, and then monetary is how much the customer spent. And then, like, you can see this, but then, you know, this is probably not that great. Like, if you even like exclude the outlier, like, what kind of information you are really getting out of this, right? So instead, you could use a heat map, and then, like, you immediately, like, recency and monetary being divided into each 5 categories of a different class. And in this way, like, I can see like where the most customers and so on. And then I can actually even change this to like, let's say like this is like equal width. So like x-axis, y-axis equal width. I can change that to different option. Let's say like equal frequency. And then like this is like x-axis, I can give it a name. So this is like a very old, small number means recent. So very, very recent, middle, old, very old. And then like what I want to do is the other one, the monetary. And this one also, like I can change that to the categorization type to the equal frequency. And then type is very small, middle, big, very big. And then like I just changed that like a y-axis label. And then this is like a recency, the time scale. So like I'd rather have like very old to be left and very recent to be right, because the time usually always progress geared towards the right-hand side. So I can change that to the order. So I could go to the x-axis property and x-axis sort order from right to left. And then I get this view. So like obviously in this particular pattern data, the customers used to, it's a video, that means like they didn't come back to our store for a long time, but they used to use a lot of money. So like that, this is where many customers are. I can click on it, show the pop-up and show the detail. And then these are the number of customers that I should give this list to the sales group or marketing group and then do some kind of promotion or campaign and so on. So that's the data wrangling and the charting. And then the charting side, and then one another thing is, let's say like if I go back to this like a summarize step and I open the summarize dialog, let's say like I want to see like which country each customer are coming from. And I can click on it and then select the country information. And when you change the country, like right now the unique number of the country, but you can just used to be like you select the first or last, like so last order, like which country of the country this customer is order from. But there's a function called mode, M-O-D-E. This is actually a new function, but it's very cool. The most frequent value. So let's say these customers order from like UK, US, Japan, and multiple countries. But most of the time, this customer order from US, then we want to pick US, right? So that's what the mode function is. So by using it, and then it returns the most frequent country for each customer in this case. So then like if I go in here, and then like if I go to the table view, now like I have the country column. What I want to do is, let's say I go to the chart view, and then like I want to show which countries they're coming from. And then like typically like I want to do like use a bar chart and then a country, and then like let's sort by number of the customers. Like let's say like I want to set let's use a sum or something like that. So this is the problem that I was talking about, because we have, how many countries we have? Country is like we have 165 countries, and then the chart tried to show like 165 bars, and then it's kind of like hard to see. And this is where like we can just use the limit values. So click from the x-axis property, limit axis values, and select a type. So in this case, let's start with the top. And top, let's say like 30 countries. And then now it's based on the current Y1 column. What is Y1 column? Here, the Y1 is the sales sum. So right now, basically, like we are seeing the top 30 countries based on their sales amount. If we want to change based on the number of the customers or something, you can do it. And you can just, all you need to do is change this column. Let's say like a number of rows, because each row is a customer now. And I can just change that to here. So this is based on the number of the customers we're seeing at top 30 countries, but each bar is showing the sales amount for each country. So, and this is pretty convenient. And the other thing is convenient is, let's say, oops. I went back to the original step before I start doing the aggregation. And then let's say like I want to show the relationship between the sales and the sales comp. These are like two columns, two numeric variables. And then if I show the trend line, here we go. And there's some sort of like correlation between these two, but it's kind of hard to see. Like, I mean, there seems to be, but what that mean? So, and then even like if you exclude the outlier, and then you can say like, yes, there is a linear sort of a correlation, but it's kind of hard to judge like what type of the linear correlation between these two. And that is the box plot chart comes in. And then this, I personally really excited about this because box plot usually, typically you use it as, trying to understand the relationship between the categorical column or variable and the numerical variable. What that means is, for example, let's say there's a region, and then like I want to see like a sales, and then this is where like, so each region have different like range of the sales or like all sales numbers, but we can actually assign a numerical variables here. So let's say like I'm assign a sales comp. So this configuration is exactly the same, right? Between this scatter. So like sales compensation is at the x-axis, and then sales is at y-axis. But now I'm using the box plot. That means x-axis is still category, but these categories are based on the numerical values. And I can change that to, for example, different amounts. So let's say like a 10 or something. And then like I can see that like each range of the sales comp has different range of sales. And by looking at this, I can see like there's some sort of like correlation, like sort of a correlated relationship between the sales and the sales comp. And then not so obvious, as obvious in a scatter plot, but this one, I mean, it depends, but I think to me, this is much better to sort of like communicate that there is a relationship between the sales and comp and the sales. But that relationship goes kind of like slowed down. So after this particular, around this point, there's not much like sort of like increase, right? So that says maybe like we can, one of the hypotheses I can say is like when you increase the sales comp and the sales increase as well up to the point of like around here, but after that like it doesn't really matter. So you can do something, use this like a binning feature, and then this binning feature is also pretty cool. Let me just use another data here. So this is like an employee data, and then I can use, let's say, the bar chart, and then I'm assigning the job role as x-axis, and the y-axis is, let's say, not y-axis. So this is like a number of the people for each job role, and I can assign monthly income to color. So again, this is like numerical values, but automatically categorized to like 5 different classes based on the values. And you can change these options, or if you don't like category. But in this case, I want to keep it in the category. And then you can say here, is this like an equal width, right? So I can quickly see like a manager and a research director may have a lot more people. There's a number of rows. Each row is an employee. So like most of the employees are in the higher range of the monthly income. And this actually is pretty convenient. And then not just the equal widths, you can actually change that to like outlier categorization. And if you do outlier categorization, there are different options. Let's select standard deviation, maybe it's 2 or something. And then like you can actually apply, then I can see like in the organization, outlier of the monthly, based on the monthly income, mostly can be found in the manager and the research director. If you want to find outlier in each job role, then like you can actually change this group by option to x-axis instead of all. Then like basically here, like we can see like in each job role, these are the upper side of the outlier, and then this like lower side of the outlier. And then like how many people, who are they, type of things. You can find this information right away. So this categorization of the numerical values can be used for color, x-axis, y-axis, and for, among many different charts, and very convenient. So it's a pretty cool feature. So I think that's it. It's already 12 o'clock. I'm going to end this session. I'm going to post the blog, basically talking about all the stuff as well. And also during the session, like I find is some of the stuff was requires some special knowledge, and such as regression or statistical tests and so on. If you're already familiar, and then you can go ahead using those. But if you're not, stay tuned for some of the online seminars I'm planning to do over the next few weeks. Okay, so I'm gonna stop right here and then open up for like a question Q&A. If you have any questions, please, you are muted, so you can click on the mute button left-hand side bottom to unmute, and then you can speak, or there's a chat window open, so you can